So many are still asking for links. So let's start anyways. I will not be able to help everyone because it's time. I cannot wait more. So let us start maybe in 1 minute. Okay, so now we have good participation. So let us start. I'm going to share my screen first, and I will also share my video for a minute. So hope all of you can see me. I'm Premjit, and some of you may be already knowing me, and some of you may be completely new to me. I'm Premjit, and I'm a structural consultant. I am settled and I practice at Bangalore, and I also train a lot of students on structures in addition to my consulting experience. So that's just about me. I will just brief you a bit about my career as well, where I started and where I'm heading to. So let me just share my screen and you will be able to see my profile as well. So let me share. I hope all of you can see my screen now. You can pick up your mic, but then you will have to mute immediately as you start, because otherwise it will be a disturbance for everyone. Please mute your mic so that it's not a disturbance for others. Okay, so we'll be focusing on this particular topic, that is how to be a successful civil and structural engineer. So now if you are a consultant, how to be successful as a consultant. If you are a student, how to be successful in getting a job. If you are a drafting person, how to plan your career. So all these are what we are going to discuss today. So can you please mute all of you? Otherwise I will have to give you that, not give you that option. So please mute yourself. Please remember to mute yourself. Okay, so before getting into the topic, let me just brief a bit about me. I have about 20 years of experience as a consultant, and I run a consulting firm called Design Dimension. You can check the website www.designdimension.com to see my projects. And civilara.com is, of course, my training initiative, and you can see that Civilara is a brand, and you can look at that and then understand what our various operations. And in case if you like to connect me, you can connect me on LinkedIn. I'm an open network, and you can see me at Premjit Vasudevan. So I will also show you my LinkedIn profile so that you can come there and connect me. LinkedIn.com, Premjit Vasudevan. If you search, you should be able to get me. So the entire profile you can see there, you connect me. The advantage of connecting me would be that you will be able to be in my network, and many consultants are my connections as well. So you will have better connect with these consultants. So that will help you in your job hunt. I will also give you exact tips on what you have to do in order to achieve this connection and various benefits from the networking. Now, before starting my own in 2015, I have been working with a company called Atkins, which is a multinational company, a UK-based company, and focusing on building and infrastructure projects. So after being a team lead for a few years there, I moved to a company called Total Environment, which is a premium builder who has everything in-house, including structures. I was leading their projects and structural design team in Bangalore. Prior to that, I have worked in companies like Jurong, Sterling, and Potential, and then I switched over to Atkins, and then now I have my own practice and my own training. And my entire expertise is on building structures and underground metros. I don't have any other specialization. I'm focused and I'm dedicated to building structures now. I don't have any other intention to get into any other structures. I'm dedicated to buildings. I will tell you the importance of being dedicated to one discipline and focusing on that in the webinar. And as I said, I have mentored thousands of students on various building related topics. Now, coming to the topic, what should freshers do to get that first job? So can someone pick up the mic? But if you are picking up the mic, please ensure that you mute yourself so that I don't need to juggle between switching off your mic. So somebody please pick up the mic and tell me, what do you think you have to do? Or what have you done and what have you failed in? Anybody?
Hello.
Yeah. Who is this?
Yeah, it's me, Mr. Abhilash Tadas.
Yeah.
From Nagpur.
Yeah.
The first thing what we need to get acquainted is with the softwares. If we know the software, it depends upon what field we have to go. It's like we have to go into designing. So I think we should know about the softwares and the basic knowledge of like civil engineering and structural engineering. I think that's the first thing what the freshers need to know.
Yeah. Yeah. Thank you. And please mute and let us continue. Yeah. What you said is right, but then there is a method for learning software. So I'll be talking about that in a while. So the first thing that you need to do is to understand your weakness. Everyone has a weakness. I have a weakness, you have a weakness. As a student, there is a huge gap in education. Some of it may be your problem, some of it may be your university's problem, some of it may be the curriculum problem. It could be anything, but the fact is that there is a huge gap in education. That existed even when I started, that exists even when you are finishing right now. So there is a huge gaps in education. The student who covers this gap as soon as possible is going to get as soon as placed. There is no doubt about that. Now, what is this gap? Some of it we have been discussing in the group. I spoke about pinning, fixing the base. There were some answers. I spoke about providing sleeves in a beam. There are few blogs that I shared. If you have seen them, I have not shared a blog which is not useful. Everything had some or the other gap that you might not have seen in your college education. So I write blogs only on those topics which are having gaps and which are not discussed in college curriculum. That is my motto, to educate students, to cover the gaps in education. That's the only intention of my blogs. So if you have not read my blogs, please go civilara.com/blog and read all of them. You will get one or the other blog which has covered gaps in education. Now, what do you mean by gaps in education? I will quickly discuss one particular thing and I will show you an ETABS model to make you understand that. Now, here you have a ETABS model. I have quickly modeled just today morning, just for showing you some of it. So you can see here, there are 4 columns in this particular plan. Can you see this? There are 4 columns. Now, many students don't understand. If I show you the bending moment diagram, see, everything is of same span. This is 6 meters, this is 6 meters, 6 or 12 meters. I'm not remembering it right now, but whatever it is, your grid 1 beam as well as grid 2 beam has the same moment or same span, I'm sorry. And if you can look at this, the only difference is in the orientation of the column. Now, because of the orientation change, you can observe that here your moment is something like 223 or something. And here you can see the moment 381. So the orientation of the column matters. It has a huge difference in the beam deflections. You can see here the span moment is 727, whereas here the span moment is much lesser. Yeah, so here support moment is more, here support moment is less. So it's all governed by the stiffness of your joint. Now, in your college, when you learn theory of structures, your BC Punmia textbook or any textbook that you are following will have comments or questions like, I changed to 2I. Have you observed that? I, in the first problem, it will say I. In the second problem, it will say now I becomes 2I. Now, the textbook or the teacher doesn't tell you, or you don't ask the teacher what is 2I. You think that change in size is increase in inertia. It need not be. It can even be an orientation change, because here you can see that the orientation is different. So B D cube by 12, this becomes the D. Your inertia increases. Here the inertia is less. So the moment attracted is less. Here, your inertia is more, the moment attracted is more. Now, what do you mean by moment attracted is more? That's because the fixity is more. Now, because the fixity is more, your deflection has reduced here. It's like somebody's holding a blanket in two hands, very much stretched tight, and you are loading it with a stone in the middle of the blanket. If you are holding it very tightly, then the deflection will be less. If you are holding it loosely, the deflection will be more. Same way, your column is tightly holding your beam, or this joint is more stiff, so the deflection is less. So you need to be able to appreciate these kind of differences. It's a very minor difference. Some of you may be already knowing that, but then there are many more things like this. So this is a very simplest form of explanation for stiffness difference, or stiffness playing a role in your analysis. Now, yesterday in one of the group, I have multiple groups for your understanding. And in one of the group, if you are from that group, you might have seen one student had asked about a stat, beam being a cantilever. Why is it behaving as a cantilever? Yeah, so all this comes from understanding. If you know how you need to model and how you have to manage, then you will not have that kind of issues. Now, the beam sizes, the column sizes, the orientation, the position of your other columns, position of your shear walls, everything is going to have a say on the load distribution. Everything depends on the stiffness. Yeah. And when you have lateral load analysis, it becomes a lot of important that you understand this behavior and then decide upon that. Now, I have smaller frames here for your understanding, so that I will display the moment here, so you will be able to see it very, very clearly. So here you can see the moment is 221. Here you can see the moment is 160, something like that, 182. So it's less. Here you have much higher. You can see here the span moment is very less. Here you can see the span moment is more. So if you know all this behavior, you will be in a position to decide the orientation of the columns. Mind you, this is a very simple frame that I have shown you, but when you have a real project, you will have to decide the column orientation. Architect is not going to decide that. You have to decide that. Now, what is your advantage of knowing how to scheme your building? Scheme means where to provide beams, where to provide columns, how to orient columns, all this. If you have an excellent understanding of this, how does that benefit you? When you go for an interview, there might be some questions which are going to focus on these. You may not realize it because you don't know about that. You may think that you answered it because your answer was correct as per your textbook, but the consultant was expecting something else. You don't even know what the consultant was expecting because you don't know what you don't know. So the first thing is to understand what you don't know. More than what you know, you need to have a good idea on what are the gaps, what you are lacking, and what a consultant is expecting. So you need to know all these things. You should be in a position to scheme a building. If you get an architectural drawing, you should be in a position to scheme it up, go to the senior and then say, okay, I know this is what I have done, now correct me. If you don't do that, you just go to him, give me the beam positions, then he'll be annoyed. He's not expecting MTech in structures or BTech in civil to go to him and get everything spoon fed and then come and sit on the floor and just model in STAAD or ETABS. That's not the expectation of a consultant in the current times. So if you have enabled yourself, if you have seen enough drawings, if you have seen enough architectural drawings, if you have practiced your own to scheme, then model it, keep on changing, keep on experimenting your column positions and orientation and understand, feel the structure. If you have done that, definitely the consultant is going to understand that you have played around with the structure, and there are high chances that you will be given a job. Without doing that, you are not going to get a job. If somebody asks you what the orientation difference makes in the structure, if you are not able to judge that based on your experience, based on what you have experimented in the structure, in the model, you won't be in a position to explain it and you won't get that job. And believe me, there are many students who are able to do that now. Internet has been an explosion and there are good students who have made use of it and who are aware of it, even when they are doing their studies. So such students, you ask them, they never have a problem with the job. The problem comes when you are taking things for granted. When you think that a CAD center learning and a modeling knowledge is adequate for your placement, rest of it is a consultant's responsibility to teach you. If you think that way, you will end up in trouble. So please skill yourself, experiment on your model, understand the behavior, scheme drawings, learn studying drawings, understand architectural drawings, start placing columns in that, start placing beams in that, understand it, and then you will start enjoying your work. Now, this is a very small difference, as I said. Like that, there are hundreds and tons of it. Now, coming to another question that I had already asked, pinning versus fixed. Now, many people told me many answers. So let us see what is the answer. Give me a minute. So I'm going to take these two frames and then create a new view. Now I will display the bending moment diagram here. What will be the difference when you fix and when you pin the base? Now, if you have fixed the base, there will be a moment developed here because everything is restrained. Yeah, I will better sketch and show you that. If you have fixed your base, your moments are going to be like this. You are going to have a moment here. And if you pin your base, you will have no moment here. Now, this is a technical difference. Now, which will you adopt at site? In reality, as I said on that day in one of the groups, see, this is what you have. The condition is this. Yeah. So here you are not pinning, you are not pinning, you are not fixing, you are not doing anything here. So now why do you insist that you have to do here something? Now, pinning and fixing is a improvisation or a thumb rule. In reality, it is neither fixed nor pinned. Here also, it is neither fixed nor pinned. You might have heard about fixed beam, fixed end moments, but I just now showed you, if the column is like this, fixity is less. If the column is like this, fixity is more. That's why it developed more moment at the joint. Now, if you increase the column size, the fixity also will increase. If you further increase your column size, the fixity is again going to increase. Now, where is that fixed condition coming? The fixed condition comes when the column is terribly large and really stiff. Yeah. So in our building structures, you don't have that huge columns. It's all 200 by 900, 200 by 600 for medium projects I'm talking about. Now, there is no fixity condition. It's all relatively fixed. 200 by 900 is more fixed than 200 by 600. 200 by 600 is more fixed than 200 by 200. Yeah, so it's relative fixity. And that's what we call as stiffness, and stiffness plays in the structure. Yeah, so in reality, that's the reason you are not fixing your columns, beam joints in your structure. You are leaving the stiffness to play. Now, when it comes to the base, why do you have to fix or pin? Because it's difficult to model a foundation and bring in the effects of soil here. Yeah, here surrounding your beam and column, it's all air. You don't have any interaction between air and your structure. But when it comes to the foundation, the foundations are on soil and the soil and foundation is interacting. If your soil is weak, the interaction is different. If your soil is hard, the interaction is different. So you should capture, or you should also model the soil below the foundation, which is difficult. You can do it in ETABS or in SAFE. You can bring in the effects of soil, but then that is not really easy. And that's not really required until and unless you are designing a burj. If you are designing a normal medium structure, bringing in this is too much. It's not really needed. So we go with a thumb rule, or we go with a tested method, either fix or pin. Now, if you ask me fix or pin, it depends on variety of factors, which I cannot cover in a quick discussion like this. But I can tell you one thing. If your structure is resting on isolated footing, and if your if your structure is an isolated footing, you can very well pin it. If your structure is on a raft, you can fix it. If it's a pile, you can fix it. If your soil is weak, compressive, you can pin it. If your soil is very hard, you can fix it. I will come with a dedicated video or a webinar on that topic, because there are too many things to discuss on that. But in a normal case, if you are having soft soil or if you have isolated foundations, you can very well pin. Your life will be much easier. Now, what happens when you pin? Your moment, column moment will go up. You have zero moment here, which means your foundation will be smaller because you don't have to pass the moment onto the foundation. Whereas when you fix, what happens? Your column moments will be lesser because it gets distributed between top and bottom of the column, because here it won't be zero, it will be more, which means that this moment will have to be transferred to the foundation. So your foundation size are likely to be larger than when you pin it. So when you pin, your column is slightly heavier, your foundation is lighter. When you fix, your column is lighter, your foundation is heavier. It all depends on project to project, but then this is something which you need to keep in mind. Fine. So that tells you the story. Now, which is right? Both are right, because both are equally right or wrong. The real thing is you have a foundation and you have soil below that. Until and unless you bring that effect, you are not accurate. So both are thumb rule-ish approach, but both are time-tested methods. You can go with that. But one important thing is consistency. If you pinned your base and released your foundation, after 1 month, you felt like your column is heavier, don't go and fix now, because you have already released your foundation, which is smaller, and site has started constructing that. Now, for making your column more economic, don't go and fix and then say, okay, I have achieved that. That's wrong. Have a consistent approach. If you pinned it throughout the project, you have to pin it. If you fixed it throughout the project, you have to fix that. If you approach that, generally for a medium structure, you pin it, you fix it, it doesn't make a difference. Your structure will stand there. But both are approximate methods. Okay, so if you know these kind of things, if you are knowing all this, if you have done this, if you have tested this, if you have asked your seniors, if you have done this in an internship, it could be any way. It could be from a training, it could be from a teacher, it could be from your own research, it could be from your friend who is a consultant, it could be Googling, whatever way. If you have covered this gap and if you have answered this question when somebody asked you in an interview, then of course they know that you know this. Yeah, so these are the kind of things that you need to focus. And this is not rocket science. And don't say that as a BTech fresher, how am I supposed to know this? You should know that. If you take an extra interest, you will know it. If you have not taken, yes, you are an ordinary person. You are not fit to be a consultant. That's the mind of a consultant. Don't take me wrong. I was like you when I started. I was lucky enough to get into a design job initially. Some of you may be lucky, but then if you put this extra effort, your reliance on that luck will be lesser. Your reliance on what you know will be more. So please spend your time on this. Some of you have raised your hands. Any question you can ask me very quick because we have less time.
Good morning, sir.
Okay, this you can ask. If your question is about how do you fix or pin column in reality, there is no different method. Whatever you detail, it stay as pinned or fixed. It's all about redistribution. I will give you another blog on that topic. or I will discuss a similar topic in the during the session, which will make you understand what is redistribution. Yeah, our structure has immense possibility to redistribute the load. If you make one mistake, until and unless it's a severe mistake, your structure is not going to come down. I will explain you why that is. And along with that, you will understand this question of what do you mean by fixed? I mean, how do you achieve that in site? You don't have to do anything special. You might have seen some people saying that if you have to achieve pin, you have to detail it in certain way. If you have to achieve fixed, you have to detail it in certain way. No, it's not really needed. It will become that. Okay, I will come to that. So I told you one example now about the gap in education. Now, the next thing that you need to do is to know the latest technology. You need to be sure of what are the leading softwares that are used in good companies. STAD, ETABS, which one would you prefer? If you are applying to a company like Atkins and then say, for building structures I'm talking about, and if you say that I'm really good in STAD, that's not great because all modern companies use ETABS. Only very small companies and very old companies and government organizations use STAD for building structures at this point in time. ETABS has clear advantage over STAD in building structures. No doubt about that. I've been using both. I can close my eyes and choose ETABS for building structures. Next would be to know the consulting practices. Yeah, what you see in textbook, what you see in reality will be completely different. The kind of diameters that you use for detailing in textbook and in reality will be different. So you need to know the consulting practices, the way in which you prepare the drawings, the style in which you prepare the drawings, the way that you document, the way that you take care of revisions. Yeah. See, you issue one drawing to site. After 2 days, there is a revision, you send that again. So now site should not get confused, which is your final drawing. So there should be a process. So these kind of things, consulting practices, you should know how you detail. I told you about the location of a sleeve in a beam. How do you decide that? All these are small, simple things. If you know, if you think, if you take enough time to learn that, you take hardly 1 minute to learn that. But then if you think about that, then that's enough. Then you should know the project cycle. Somebody was asking in the chat, where to start, where to end. That's a good question. Beginners are always confused on where to start. See, you need to have good visualization skills. You should be able to understand what is a building. You should be able to study architectural drawings. You should be able to understand other stakeholders' needs. You should be able to convey what you want. So all these are important things. You need to have ability to scheme a building. So first thing that you should do is to visualize a building. What are the building elements? How they are placed? How are they oriented? Where do you need beams? Where do you need columns? What should be the way it should be oriented? Things like that. You should be able to study a structural drawing. You should be able to study an architectural requirement, load calculations. All these are very important. Yeah, so that's the place where you need to start. So all these are equally important. Latest technology, gaps in education, covering that, consulting practices, the project cycle. Now, what is a project cycle? Very simply put, it includes architectural drawing production. That is more of an architectural role, but then architects, client, and structural engineer should sit together because you have inputs. You need to tell them, where do you need shear walls? Otherwise, what happens? You get a drawing. If you don't give your inputs, you get a drawing and your shear wall is here. Now, what happens if your shear wall is in a corner? See, you have lateral load. This is the plan of the building, okay? And you got a very stiff shear wall in the corner of the building because architect decided that the lift core will be here and here only he will give you the lift. Now, the shear wall. Now, what is the problem? Here it is very stiff. Here it is very plain. So what happens when the ground moves, your building will twist. Why? Because here you have very, very huge stiffness. Here you don't have any stiffness. So your building will rotate during earthquake, which is going to create a lot of torsion and brittle failure in your building. Yeah. So as a structural engineer, you should be able to decide, okay, no, this is not the place I want. Probably this is the place I want. If not, what is the corrective action to be taken? All this you should know. But as a beginner, you may not know that, but then yes, at least this much knowledge you should have. What is earthquake? Many think that earthquake is a wave coming and hitting your building. No, it is not a wave coming and hitting your building. It is inertia. You have a bus, say, and you are standing in a bus. Bus moves. What happens? You feel a jerk. If you are not holding anywhere, your building, your weight is going down to the center of gravity or center of the earth. At the same time, you are being pulled. What happens? You try or you continue to be in rest while the bus moves. Because of that delay, you experience a lateral load. So your own weight, 100 kg, if it is your weight, becomes a lateral mass because of the inertia. Same is your earthquake. Earthquake is not a direct pressure like wind. Nothing is coming and hitting your building. No, that's not earthquake. Earthquake is ground movement. And because of the movement of the ground, like when you are in a bus, the building experiences inertia, and that inertia is your lateral load. If you know this, there is a huge difference in your understanding on what earthquake is. So now, what is the difference between wind and earthquake? Wind is a pressure coming and hitting your building. What is earthquake? Earthquake is ground movement, and the deflection due to inertia is creating additional load in your building. So if a consultant asks you, what is the difference between wind and earthquake? If you say both are lateral loads, both are same, it's wave coming and hitting, and one is wind coming and hitting, you are out of the job. You are not going to get that job. So you need to have this fine logical understanding of what each of the aspect is. If you connect what you learn in your college to logic, to practicality by logical means, you always have a difference from other candidates. Yeah, so try to relate everything to reality. So that makes a huge difference in your understanding of structures and your performance. I will give you time to ask questions in the end. So please wait. If I give you time now, then we are going to reach nowhere. Now, once you cover these gaps, and if you are sure that you know things, then you need to connect with people who are relevant. Now, being in LinkedIn is not enough. You need to demonstrate your ability on LinkedIn. Now, how do you do it? I will show you the example of one of my students. You can check, many students are there. Now, I am remembering somebody who had done something recently. So I will just show his profile to you. Yeah. So what you need to do is you need to demonstrate what you know. Engage with others when they ask a question. See, many senior engineers do post challenging questions and posts and projects in their profile. Now, if you see that and then just leave it, they don't know that you have seen that or you are interested in that. You have to comment. And more importantly, it should be something positive and something that showcases your knowledge. If you do that, definitely that consultant will take note of you, your interest, your understanding, and next time he has a vacancy, he will talk to you. So that's how you engage. Just being a connection or just being in LinkedIn is not at all useful. You have to engage with people. You have to be in groups. You have to answer questions. You have to ask questions. You have to comment. That's how you understand. Take out your inhibitions, but comment properly, positively, no negative comments, because social media is such a place where a negative comment, it could be valid negative comment, but then try to stay away from negativity. People don't like negativity. Yeah, positive attitude is very important for any job change or for any job hunt. Now here, this guy has done a complete detailing of a structure in Revit. So please mute your mic. So you can see here, everything is detailed out. Everything is called out in a consulting way. 3D details are provided. So any consultant who want to migrate to Revit, I am sure that if he has noticed, he's going to talk to this fellow. Yeah, so he has showcased here what he has done. Revit structures. My full project work using Revit consists of 3D modeling, this project was possible. Okay, that's yeah, he's my student, so he has tagged me for that. So that tagging will also increase his visibility because he's going to be seen by people in my list also when I comment something. So that's how you attract seniors and demonstrate your skill set. You also need to engage with others in discussions and asking your doubts. There is no problem in asking a doubt, but ensure that you ask it in the right manner and the right questions. Yeah. So if you have that sensibility to understand what you need to ask, please go ahead and ask. That will only increase your visibility and your possibility of being seen. If you don't do it, then you are hunting job in a conventional way, which may not work in this current situations. Coming to next.
Sir, what is the meaning of a relevant title block here?
Pardon me?
So what is the meaning of relevant title block that he has mentioned in the description?
Which
so that LinkedIn profile, yes, relevant title block.
What is your question? You mean the title of his post, is it?
Yes, yes, sir. Like he has mentioned creating sheet with relevant title block. So sir, what does that mean?
So he has put every drawing into a sheet and he has given the notes. Everything is here. See, you can see, if you see here, Autodesk, if you replace it with a company logo, this is in a good for construction format. You have the layout, you have the drawing name, you have the revision number, everything. So it's in a title sheet. That's what he meant. You also have the general notes that generally needs to be given. Yeah, there are scope for improvement in this, but still he is a fresher. So I appreciate what he has done. So you should be in a position to do that. You as a structural or a civil engineer is complete when the design drawing is also prepared. Don't think that only analysis is important. Being in office and doing only analysis is not a great job. You may think that that's great, but even if you're doing 30-floor building, it's meaningless until and unless you know to convey it in terms of a drawing, because the client knows only your drawing, not your analysis model. Yeah, that's a big thing for success. Now, what should site engineers do to shift to structures? Before that, I told you how to demonstrate your skills. There are many more ways. Those who are interested, or I can give you the links to my blogs and videos after this. Please remind me. If you don't get it, you please email me or WhatsApp me, or I will put it in the group. Now, keep improving your skill set. Yeah, every day you have to keep on improving. Don't lose your heart. Every day you keep improving, do projects and improve your understanding on structures. That's how you perfect. There is no easy way. Now, coming to what site engineers should do to shift to structures, more or less the same. One more point I want to add is that you can perform better as a site engineer if you know structures. If you don't understand what I mean, you can go to this particular blog and I'll put it in the chat, or I'll just show you very quickly. You can go to civilara.com/blog post bar anchorage. Some of you might have seen this, some of you might not have seen this. Now, everybody thinks that anchorage length is 50 times diameter. That's horribly wrong. It need not be 50 times diameter. Many times it can be lesser. Many times it can be, or it may have to be more. It depends on a lot of parameters. Now here, see, it's a straight line. So do you have to bend it down? Sometimes your senior may say, no, you have to bend it down. You might have already tied your reinforcement, but you have not bent it down. Is it really mandatory? Not really. If the straight length itself is giving you the development length, why to bend it down? Not needed. If you know this, you can challenge your structural engineer also. Sometimes don't believe that all structural engineers are equally skilled. Some may be pretending as a structural engineer, especially in India. Yeah. So if you have not bent it down, and if somebody asks you to bend it down by removing the entire site work that you have already done, but if you are sure that a straight length is enough, that straight length is giving you that development length, then why to bend that down? It's not needed, but you should know how to calculate it. Now, sometimes say you bend it down as well, but then it is short than what is mentioned in your structural drawing. So is it fine? Many times it should be 100 millimeter difference, maybe okay. Why? Because if you know the formula for calculating the development length, it has sigma here. Now, many people, even experienced structural engineers, take this as 0.87 Fi. If your grade of steel is 500, 0.87 times 500 is sigma s. But in many cases, please listen carefully. In many cases, what happens is you might have rounded off your steel. What I mean is the steel needed here is 250. Now 212 is 226 millimeter square. But your structural engineer might have given it as 216 because 212 is not sufficient. Or he might have given 212 plus 212, which means you have 400 millimeter square, which also means that the stress is half of what you have. Sigma s Fy is fully stressed bar. 500 will come if you are fully loading it. But now you have given more steel than needed. So if you have given double steel than needed due to the detailing round off. Yeah, you're getting me, right? See, 212 is 226, but your design tells you that you need 250 millimeter square. What do? 212 if you give, it is less. So the consultant would have given 212 plus 212, or he would have given this as 216, which means you have 400 millimeter square steel, which means your stress is not 500. You are not reaching anywhere near that. It is half or 3/4 of that only, or 1/4 of that, right? Yeah. So only that much, or 3/4 maybe. Yeah. So you have margin in your LD. You don't need LD equal to 50 times now. Yeah. So if you understand this, if you made a mistake, then you can request your structural engineer, can you check this? Can I go with this? Sometimes even structural engineer may not be knowing about that. That the sigma s is the actual stress, not the full stress. Yeah, so if you have rounded off, or if the structural engineer has rounded off that sigma s, I mean the steel, you have more margin, which means your LD can be lesser. So as a site engineer, if you know this, you can challenge and you can make mistakes right. I'm not saying that you should make mistake. I'm saying that many times your mistake is not a mistake. If LD is slightly short, you may be okay with that. If you know, you understand that, and then you can talk in that language. If you don't know, you will have to unwind that and redo everything. Yeah, so it's up to you. You need to know structures if you are a site engineer. Another example, say you have a water tank or a retaining wall. Let us take water tank. Okay. Now the consultant has put a note. Backfill, it's an underground tank. Backfill the wall only after you put the cover slab. Or backfill the earth only after you put water. What does that mean? That means that he has taken only the water load. He has not taken this load. Now, why is he putting a note, load or fill the water only after the cover slab is cast? If that note is there, what happens is your wall, if you have a prop, that is a slab coming here and connecting to the wall, will be acting like this. So here your moment will be more, here it will be slightly less. If this is not put, that is going to be a pure cantilever. And this moment is going to be very high. So he has not taken care of that. So that's the reason he's telling you that construction sequence. Load the water only after your cover slab is put. So he's conveying that in that manner. So if you miss the note, you are likely to have cracks. So the order of construction, the order is very important in case of these kind of structures. Same way, if you have done the free course, I had mentioned about stability of a lintel. Those who have understood that would appreciate it. See, you have a lintel chaja from a lintel, and this is a cut lintel. Why is it standing there? I had explained it in the free course. If you have not done that, please go and redo it. So these are all going to help you if you know structures. Site engineering is nothing but application of structural engineering, yeah, especially the detailing part of it. So if you know structures, there is a clear-cut advantage in your performance if you are a site engineer. Many different ways you will get benefited if you know structures. Even if you are a site engineer, you can appreciate it and start enjoying your site work. Yeah, and how do you switch to structures if you are a site engineer? You can do it. You can do it by practicing. You can also take up dual roles. What I mean is, many architects, they are open to give smaller work, 1 floor, 2 floor buildings to a beginner. They don't mind that because they also have some experience by doing what is wrong, what is right. So they will be open to explore with a new beginner. Yeah, so skill yourself only after that, not like just going and starting to do it. After doing your own some projects and validating it with a senior, you can take up such roles. Now, many architects will give you a dual role, like site engineering. You will have to go and inspect. At the same time, you say that I will join you if you give me opportunity to do smaller works in-house. So slowly help them to take everything into in-house. Yeah, so smaller work you do as a structural engineer. Rest of the time you give them for quantification, for site engineering, all that. Take up such roles. You can also ask a consultant to allow you to freelance, things like that, learn from them. Maybe initially you may have to work as a site engineer, but parallelly you tell them to give you work, and then that way you can freelance and master. In that process, you may end up meeting a consultant, and if he likes you, if you demonstrate your abilities, who knows, they may hire you as well. Yeah, so everything is based on your two things. One is skilling, and second is demonstrating your ability. Yeah, there is nothing else that you have to do but do it in the right way. Now, if you are wanting to set up your own business, say you have some experience, maybe site or whatever, and you want to set up something. First thing is, again, same. You have to have the skill, at least to understand what you don't know. And whenever you know that you don't know this, ask somebody or find a way to know that. You should not be doing foolish things, but you should be knowing that this is beyond your understanding, so you need help. If you can do that, you can start a consulting straight right now. But the only thing is, you need to be sensitive and sensible to understand what you can't do. And you should seek help at that time. And there should be somebody to guide you around. If you have that, straight away you can start. But that sensibility and understanding is very important. Lack of it is going to put you in real trouble. Okay. Now, if you want to be successful as a consultant in the current time, you should have a great process, because the payment for a consultant is very, very marginal. It doesn't have a scope for making errors and abortive works and things like that. So you should have a robust process which helps you. You should use the right tools like Revit, which allows you to manage revisions. 10 times architect revise, fine, let it be. If you do it in AutoCAD, you will do it every time. One change, keep on changing. So you need to adopt right tools for controlling revisions and changes. Otherwise, you are not going to succeed, because your fee is going to be that 3 rupees or 5 rupees or 6 rupees, whatever is there in that region. So if you have to, as a structural consultant, if you have to succeed, you need to establish a process and stick to that. Haphazard way of working will not work. You need to have limited number of staff. You should have an excellent process for your success. You should find the right clients. There is no point in working with a client who keeps on changing things, who doesn't have clarity, who doesn't have a process, who doesn't pay you. Your intention is not to get work. Your intention is to get work, do it well, and then get paid. Everything is important. And somebody who is not allowing you to work well, somebody who is asking you to compromise, somebody who is asking you to give 200 by 200 column when you need 300 by 300 is not your client, should not be your client. You have to eliminate bad people early in your career, then you are going to be successful. It may take time, but then you find 5 architects who are really good and are okay to give you work. That's the end of the story. You don't have to find now people as a beginner. But if you end up with the wrong set of people, you think that, okay, I need 10 number of projects now. Otherwise, I started off now, I don't have work. What do I do? Let me take all the work that comes my way. If you do that, you are going to end up with wrong people for lifetime. They are not going to pay you. They are going to make you revise. They are going to give you work with compromises. The building will crack. You are going to go there. Nobody is going to pay you for that extra crack checking and correction work. So find the right client who gives you right work, right money, and right permissions to work for the correct methods and code adherence. If you find that, you are set. Now work with them, gel with them, give them good work, quality work. End of the story. You will be succeeding in a couple of years. Next is find your niche. Don't think that as a structural engineer, you should do everything. If you are not knowing about steel structures, you can either say no to the client, or you can say, I will partner with somebody and do that. Find a person who is able to do that. Don't think that, okay, everything I have to do. It's not like that. It's a time for partnerships. It's a time to learn from others. It's a time to have all this. Yeah. So stick to your strength. If you are good in steel, yes, stick to that. If you're good in PEB, stick to that. I'm not saying that you should not master the other. Yes, you have to, but then straight away, you should not take hundreds of projects or tens of projects where you don't have knowledge and then you spend more time there. So rather than spending more time there, outsource it to somebody who knows that. Even if you give 100% of the fee to that person, that doesn't matter. You are keeping the client. The next project, maybe you have more time and then you can do your research. Yeah, so stick to your strength. Maximum project should be your strength. If something else comes, yes, well and good. You partner with somebody who has that skill set and give that guy even 100% of the fee, doesn't matter. Partner with seniors who can help. Both are covered. Yeah, so that's how you succeed as a consultant or as a beginner. That's how you need to establish. This is very important. I have done that. Luckily, somebody was there to advise me. I had a mentor and I adopted that. I don't have hundreds of projects. I do very limited number of projects, but I'm happy with what I'm doing. I don't compromise a bit. If somebody tells me to compromise, I walk out of that project. And that comes with confidence. Everyone should have, everyone can do. If everyone does that, then no one will ask you to compromise. Am I right or wrong? Why are compromises there in structures or in civil? It's because we civil engineers are open to compromise. If all of us says no to compromise, there is no space, there is no scope for compromise. We are not united in that. So this problem starts from ourselves. Okay, now coming to freelance options. There are 3 different things that I can tell you. One is design, one is detailing, another is BIM. All these are hot now. Design simply because many consultants are finding it difficult to run full-time offices. So most of them are in online mode. So if you can demonstrate your skill, there are possibilities that you get at least the modeling part of it outsourced. But you should have tremendous skill to prove that you can do it from home. And there are many consultants who are doing that. Second is detailing. You should have excellent understanding of detailing rules. Knowing AutoCAD is not good enough. You need to know where to lap. You need to know where to stagger, or what do you mean by staggering of lap. You need to know in seismic structures, you may get this kind of detailing. That is, you always think that your beam will always be like this. You have more steel at the top, at the support, you have more steel at the bottom in the span. But when you are doing seismic detailing, if there is stress reversal, there are chances that you will end up with this detail also. Have anyone seen this detail where you have more bottom steel at the support? It can happen, which means that your bottom rebars should not be lapped in that region also. You cannot lap here because it's the span and you have more moment there. You cannot lap in the end zone also in seismic cases. So these kind of rules you need to know. If your rebar, if you have a suspender, say you have a mid-landing beam and this is suspended from above, this is a stair, okay? And this landing is suspended from above. There is a column here. Here you cannot have the column, so it is suspended from top another beam, say. Now this is in pure tension. Now when your rebars are in full tension or complete tension, your lap length should be 2 times LD. These kind of rules. There are many more rules like this. If you know all these rules, where to lap, where to curtail, how do you decide this 0.25 L? SP34 tells you the curtailment length is 0.25 L, but how do you identify, is that correct? Why that 0.25 L comes? Then you can fine tune your detail and make it more economic or more safer. Yeah, so these are the things that you need to focus on. So if you know all that, that is what I mean by covering the gaps. If you know this, then you can outsource detailing works. Knowing CAD is not enough because the consultant would ask you, show me a cantilever beam detailed. If you are not able to present that in the right way with the detailing rules that I mentioned, then he won't be confident, because then after getting your drawing, he has a lot of things to do. Same thing with beam. Now, what is beam? I showed you that students' work. I will quickly show you a simple structure that I have done. Or yeah, so this is a 3D structure which I have done in Revit. You can see the possibilities. You can give 3D drawings. I will take another one. So this is a RC detail that I have done in Revit. Now, these are not 2D drawings that I have done similar to what you do in AutoCAD. If you look at this particular structure, this is my 3D. Yeah, there is no other drawing that I have made. The entire details are inside this. See, I have superimposed. The architect was not using Revit, but still I used Revit. You can see AutoCAD is superimposed here. I took an AutoCAD into this, and on that I overlaid and did my Revit. That's why you can see the AutoCAD drawings in the background. Now, all that beam details that you saw there in that sheet is inside this. All the rebars, slab rebars, everything is inside this. I have not done a 2D drawing. This is a 3D drawing. Only thing is that I made it into a 2D view and took the printout to give it to the client or to the site. Everything is done 3D. Now, the beauty of this is tomorrow, if somebody changes the beam depth from say 450 to say 600, if the client said, okay, I don't want this beam 600, make it 450, you do your design and your drawing doesn't need any change. It will automatically change. If I change in the model, it will get reflected here also. Revit is parametric. So if you adopt these kind of systems, your abortive work or rework is very minimal, and you can turn around very fast. So the client also will be happy that you turned around fast. You can charge maybe for the revision, saying that it was a revision, but at the same time, you are not spending that manual laborious work that you used to do earlier. I'm not going to even tell him that I'm using Revit, because many clients now feels like, okay, you are using a tool, so why should I pay you? Yeah, so don't even tell them that you are using Revit. Yeah, you can do everything smartly and control your revisions, everything. You can manage abortive work, use Revit and implement that as a system, teach 1 or 2 juniors. That's the end of the story. Yeah, so that's about BIM. So if you are a master in this, see, I know one of my teammate in Atkins who was drawing around 8,000 salary when he was in Atkins. He's successfully running a detailing business now. Now, don't underestimate detailing saying that I'm an engineer. Detailing is what conveys your understanding of structures. Client doesn't know you are a great ETABS modeler. He don't want to know. He only want to know your detail. Are the barbending people at site able to do it? Is it properly done? That's the only thing that he sees. So detailing is an area where engineers don't focus. That's really wrong. Detailing is the most important, one of the most important. I cannot say most important. And coming back to my teammate story, today he has 10 engineers working under him in Bangalore. He is just an ITI person by qualification, but he has spectacular understanding of detailing. He produces barbending schedules. And believe me, he is working for projects which are much larger than what Atkins is doing right now. He is doing Olympics projects. He's doing football stadiums, everything, barbending schedules. So he get the work outsourced from UK and Middle East. And it doesn't come easy. It comes with tremendous practice and ability to prepare barbending schedule. But the basic step for doing that is appreciating the detailing rules. That's a start. Then you work somewhere as a detailer, understand the complications in detailing, master it. After 2 to 5 years, you will be a master. Then comes things like that. Same thing with building information modeling. See, people in UK, people in Middle East, they don't want to spend time on things that take time. Say, for example, if you look at US, most of the nursing jobs belong to Indians. Most of the teaching jobs belong to Indians. Everywhere, there is some kind of patience required. Wherever there is some soft skills required, people are not willing to do that kind of job in the West. Same thing with detailing. It needs a lot of time and a lot of patience. You should have that mindset to do detailing. They don't have that. So most of it is outsourced to countries like India. So if you can develop some good communication skills and ability to detail, you may be earning much better than an engineer. So don't underestimate detailing at any cost. Now, having said this, if you don't enjoy doing detailing, please don't take that up, because I don't believe in doing something which you don't enjoy. So that should be the first criteria. If you enjoy design, be there. But if you enjoy detailing, please take that as your career. BIM and detailing using BIM is the current trend. You don't need AutoCAD. You can do everything using Revit or other BIM tools, and Revit is the most popular tool. Now, very quickly, I will just quickly introduce you to some of my mentoring programs. Very quickly, I won't take your time. Then I'm going to open this forum for questions. And I will also tell you one more important point at the end. So if you look at my course.civilara.com, you would have seen an ETABS course, which I had shared in one of the groups. So here I am covering the entire scheming, role of a structural engineer, scheming of a building. How do you need to start off? Somebody was asking how to start off things. So everything is mentioned here with examples. how to decide beam positions, column positions, everything. Entire ETABS modeling, where to decide shear wall positions, things like that. Importing from CAD, load applications, things like what is earthquake load? Should I apply the load in kilonewton per meter or per meter square? Things like that. Any question that you might have, very elaborately, you can see the load application itself is some 20-25 videos. How you need to apply load of a stair, how you need to apply the load of a water tank, everything is covered here. Then things like stiffness modification, membrane versus shell, torsion. I had asked you, I guess, release of torsion, things like that. How do you result interpret? What are the checks that you need to adopt to ensure that your ETABS is correct? Manual designs, shear wall, column, everything. Then there are quite a lot of additional videos on various load combinations, things like that. I keep on adding here videos as and when I publish something new. So this is a premium course that I'm offering. And if you look here, you have different plans. Forget about this 15,000 plan. That's not there at this point in time. That's a live course. You have 3 different variants here, which I'm giving you. In this case, all the 3 cases has the same content. Only difference is in the access time. So you can see here, this is 3 years access, this is 1 year, and this is 6 months. And other difference is the number of extra homework that I'm going to give you. Otherwise, the content is all the same, no difference. Because some students say that, okay, I can only afford this, so that's why I have created that. Only thing is the time duration and the number of extra projects is different, and my involvement. If you're taking this 10,000 plan, you get a full mentorship from me, like you are getting a community there. You are going to get a community inside the login, and I'll be communicating with you all your doubts. In this plan, it'll be less. In this plan, it'll be slightly more, but here you get my full support as well. So this is going to give you complete independence on a tall or a mid-rise building, I would say. I wouldn't say super tall building, but say up to 15, 20 floors, you will be in a position to do it. You can ask me doubts, you can scheme, you can design, and you can detail using the methods and things that I mentioned there. And those who are attending this webinar, I'm going to give this 10,000 course for 8,000 today, and this course for 6,000. And this course will not have any reduction because my course is valuing much higher than this. This is a special plan which I have created for people who cannot afford. So there won't be any offer for this. So here, this will be available for 8,000 and this for 6,000. And there will be much more benefits which I will share you in the group or in the email that I'm going to give you if you are taking this very soon. Now, another thing I want to tell you is about BIM. Here there is a Revit structures course. If anybody is interested, you can explore this. Again, all these courses are in an industrial way. The things that I learned working with consultants like Atkins, all these experiences are shared here. Rebar detailing to everything is mentioned here on Revit structures. So I would suggest 2 career paths. So whoever is interested can get back to me. Now coming back to the webinar part of it, whoever wants career, I suggest you 2 different paths. One is design career. Another is BIM related career. Now, who are 100% sure that I can be a structural engineer and my skills are good enough, or I can polish my skill if I have a mentor, can choose design. Then ETABS and the basics and the things are your things to focus. Now, if you are slightly confused, can I be that? Then I would recommend close your eyes and go with BIM, because this is an emerging technology. There are going to be hundreds and thousands of opportunities, even in smaller firms in India. It's like 30 years back, people used to draw on drawing boards. Yeah, drafting using a drafter or a T-square or things like that. Now came AutoCAD and revolutionized and changed everything the way we work. The same way, AutoCAD is going to be replaced. It's almost replaced in larger companies, but even in smaller companies, it's going to get replaced. And people needs a staff for doing BIM. Now your progression will be BIM modeler, then BIM manager. Like that, you can progress. The start point is Revit. And as you progress, you can learn other softwares like Tekla and other things and be a BIM master. Yeah, so you are going to know the entire BIM processes using different software, and you can progress your career using BIM. Now in BIM, now you may think, some of you at least may think like, okay, it's a diploma guy's job. It's not like that. Even diploma guys can do this. That doesn't mean that engineers should not do it, because it's quite important. And it is slightly different from the normal way of CAD. It needs a lot of technical understanding as well, in the sense specific to software, not related to your analysis. But all the good detailing rules you need to master, plus the software skills. And that software skills includes engineering application. Yeah, so you can adopt a BIM career as well. In larger multinational companies like Arcadis and Atkins and Acom, things like that, companies like that already adopted BIM. Smaller firms are yet to adopt, but in the local market, also in Bangalore, if you know Total Environment, let it be Design Tree, these companies are adopting BIM sooner or later. Yeah, so BIM career and design career in this BIM. And in between, you can also include a detailing career if you are a diploma or if you want to focus on pure detailing. So that's what I would advise. So
Sir,
one second, let me just finish off. So the thing is very simple. What you have to do is skill yourself, cover the gaps, adopt the latest technology, know the consulting practice, know the project cycle, connect to people, demonstrate your skills, keep improving. Yeah. So you can do this in different ways. If you get an internship somewhere, you are lucky. Yes, learn from there. If you can research, yes, you can do, but then it takes a lot of time. You may get confused. There may be no people to help you. You can do it in a training. You can do it by working if you get a job. So there are many possibilities. You can decide. Learning on your own will be slow and confusing. Learning in an internship will be okay, but then still there may be slight bottlenecks, like you will not get the right clarification at the right time, or take it from a training, or you get a job and do that. So how you do it is up to you, but then this is what you have to do. This is the only thing that you have to do, but there are a lot of things there to do. If you do it, success is yours. Yeah, you can ask me any question if you have.
Sir, like as you said that BM modeler work on the Revit and AutoCAD, then what is the difference between BIM modeler and draftman?
See, BIM is a process. You have to set up a lot of things. BIM is not just about making a drawing. There are processes. Say if 10 people are working, 10 people's work can be collated and combined. It's like, do you know layers in AutoCAD? Do you know layers
Yes,
system in
I know
AutoCAD?
layers system, yes.
Yes, the
Yes,
same
sir, yes,
way,
sir.
the same way, say if you, what's your name?
Sir, Shubham Keshri.
Yeah, so if you say person A, person B, person C, architect A, architect B, architect C, there are 10 people working, and each person can work on one model, okay, in their computer as different layers. Now you can collate this and bring it into one model and make it into a single model, a central file. Same way, there are multiple work sharing and coordination options, which is not just about drafting. It is about a knack. It's about a technique. It's about a technology, using it. So engineering is definitely needed for all that. So as you progress in your career, if you are a BIM manager, it's not just sitting and drafting that is going to be your job. It is all this, managing a project. Yeah. see in AutoCAD, it's all about drawing lines and things like that. But when it comes to Revit, there are some beautiful systems. So if you make a mistake in that, all of a sudden you may lose your column, you may lose your beams, you may start not seeing some of your building elements. Yeah, so now only a person who has real good understanding of how that was done can pick up that kind of mistakes and all that. You are getting me? So it's much more than excuse me, it's much more than drafting. It is establishing a process, maintaining that, and then identifying errors and keeping on your project going. So it is much more than drafting. Any other question? You can take this session to ask your questions.
Good afternoon, sir. I am Shyam Sundar from Kochi.
Yes,
regarding Shyam. There's a BIM software, we will get a BOQ also along with it, right?
Yes, you can quantify. Yeah, I missed to tell you that.
After drafting in the BIM software, simultaneously we will get a BOQ of the building also, right?
Yes, that's correct. I can quickly show you. In this particular project, I have not done that. But if you are doing architecture and if you are practicing various things, yes, you can get your quantities super fast and to 100% accuracy. 1 second you give me. I think in this model, there might be a quantity that I have taken. So I had some people asking in the group, can you teach me estimation? Now, my answer is that estimation doesn't need teaching because quantification is nothing but
methods and
it is just finding out 3 dimensions. If you multiply 3 dimensions, you get the volume. If you know the cost, multiply it with the volume, you get the total cost of that particular thing. So that's it. So now what you need to understand is that cycle that I said. What is a building? If there is a lintel, you should know that the lintel can be through lintel. You also should know that there can be a cut lintel also. And if you are able to understand that by reading the drawing, then what quantification you are talking about? You know the window, the numbers, the dimension of the windows, the type of the window, the cost of the window. So now why do you want someone to teach you quantification? It's directly readable from the drawing. Now Revit allows you to take the quantities automatic. See, you can see here the column schedule is here. Yeah. So each column, its length, 1000 length is from say foundation level to plinth level. Its volume from plinth to roof. I think this is a 3 or 4 floor building. So each column volume it is giving you. So like that, you can create your foundation schedule. You can create your column schedule. Every quantity comes automatic. Now the beauty is that if you change the size in this table, the size in the model will change. If you change the size in the model, the size in the table will change. That's what we call as parametric behavior. It is interconnected everywhere. You don't have to isolately do anything. If you change one thing, one place, it changes everywhere. If the plan is changed, the section changes. If the section changed, the plan changes. If you change the project name, it gets changed in all the title sheets. So the laborious part of your work is not going to be there. So that's the beauty.
Sir, here length means height or width?
See, let us not get into micro things here. Length means height here.
Okay.
This is foundation. So length, width, yeah, both are same because it's a square footing. Okay. Yeah, let's not get into the micro things. It gives you everything as you want. Don't.
Quantification is doing simultaneously.
Yeah.
But the material estimation means items means how much is cement, how much that is not doing here. Just the quantity we will getting here. Right?
Yes. What you model, you get that. Through. Yes. Okay. Material wise takeoff, you won't get that.
That is in another. Okay.
Yes. That you will have to do.
Okay.
Very good afternoon, sir.
Yeah.
This is Shubham, sir, from Pune. Exactly, sir. I was having a technical doubt about like floating columns, what like consultants are dealing right now. Like if we see, sir, IS 456 doesn't allow us to use floating columns, where architectures, like talking about their aesthetics, their architecture view, they need some floating columns in projects. So is it quite becomes heavier sometimes to whether we should go with that option, or either you told us like in this session you told us about that we should eliminate those projects, like we should not work on those projects. So
Yes.
it is quite tough. The statement becomes quite tough to understand me, sir, like in
Okay.
case what we can do for that.
Yeah. See, it's very simple. See, this is your floating column. Okay, I'm just drawing a elevation. Okay, say you have something like this. Okay, now the question is, should you do it? Should you not do it? Second part of it is, what if an architect forces you to do that? Okay, first thing is, it is possible to do that. I will come back to that. Second thing I will deal first. Now, first thing is you need to convince the architect about the problem with that. Yeah. What are the challenges that you will have, or what is the code telling you about that? You need to convince him. If you are not able to convince him, you have to drop, no doubt about that, because you have to meet the code parameters. If you are not meeting, then why did you study civil engineering?
Yeah, right.
Yeah. So if 100 engineers are there, only one is doing this, so that is, or two are doing this. That's the reason other 98 are okay to do compromise, and that's the reason that architects are able to get the project out of you and give it to someone else. So the first thing is that you need to be associated. That's altogether a different thing, which will take ages to become. But then I can tell you with my experience that there are many architects who are receptive of your suggestions and who want to be with you, who are on the same pages. Yeah, work with them, find them. That's what I'm telling you. There are many. It's not one or two. There are many. Second thing is, it's possible to do it. Only thing is, the code is asking you to ensure that if you have a floating column, that should not be a part of your lateral load resisting mechanism. Yeah, so this should be relieved of any lateral load, which means all other columns put together and your shear walls, whatever you have to provide, need to take the lateral forces, and this should be taking only the gravity load. That's what the code tells you. So your scheme should be made in a manner that this column is relieved from that particular lateral load, and you distribute the lateral load onto other columns. Now, your architect and the client should allow you to do that. In the scheme, there will be slight changes and differences. So you need to tell them, you need to explain them. 50% of the people will understand if you explain it in the right way. If you tell that, okay, no, I cannot give floating column. No, that's not allowed. If you only say that, it doesn't work. You have to make your scheme, explain them the differences. You need to tell them about the alternate load path. You need to tell them about accidents. Are you aware of, I'm a specialist in disproportionate collapse control. I adopt that in all projects, believe me or not. You are talking only about floating column. I'm saying that in each and every project, I'm able to adopt disproportionate collapse control. What I mean is, if somebody tells me, I want this, yeah, I'm drawing it in a very simple manner, say 10 meter, say 6 meter. I won't do this. I will make him give me another column. Otherwise, I'm not going to do it. Why? Because, see, if this is 10 meter and if it's a 20-floor building, just imagine, say a truck came and knocked this column off.
Yes.
What happens? No structure can cantilever 10 meter. Yeah. So this beam B1 has only one load path. If this fails, this has to be a cantilever. And you know that 10 meter, it cannot cantilever. It will fall. 20 floors will fall down.
Yes.
If you get one more, what is the advantage? I will draw the elevation
Beam
of that.
depth will be quite low.
See, one column. See, you cannot say that, okay, 3 columns will be knocked off at the same time. I cannot solve each and every accident. But let us be realistic. Say one column got knocked off. Now you have 5 meter cantilever. Now 5 meter cantilever also you cannot make it work because this will be 900 deep or 1500 deep. I don't know. I'm just telling you. Yeah. But think about this. During an accident, you don't want seismic resistance. Do you? Do you want? Say truck knocking off this column. Why are you bothered about seismic resistance at that time? No, I don't want seismic resistance. Do you want factor of safety 1.5? No, I don't want, because that factor of safety is given to absorb when there is an accident. So if you make sure that this structure, which had a column here, can work without a column for unfactored load as a cantilever, let the deflection be higher, no problem, because our intention is people should not die. Deflection, let it be high. I want that structure to stand there, 20 floors should not be coming down. That's the only requirement I have. And that can be met if you design this frame as a cantilever for unfactored load alone. Live load also you can reduce, because when you say 3 kilonewton per meter square live load, it's huge. You don't actually have that much load on your building. So for that load, real load that might be there in that building, if this can cantilever 5 meters, then my building is not going to fail. Yeah. So I adopt this in important buildings. I do this. So how am I able to do it? You can do it. Only thing is you need to convince people. Yeah. It's difficult. It doesn't come very easy. Yeah. But you can do that. And you should try doing that. If you fail, then you think about compromises. And still, I will say, don't compromise. And if 10 people starts telling in your area, if your city is medium city, and if you are 10 consultants, if the 10 consultants speak the same language, I'm sure that nobody can make you do something which you don't want to do.
Yes.
So have associations, have the consultants on board, have an association, talk to each other. That's how you need to develop that. And that's the need of the hour. Otherwise, we are going to be eaten away by other stakeholders. Believe me, there is no other choice. You had to be united. Any other question?
Thank you, sir. Thank you so much.
And if somebody has
as a second
yeah,
non-technical doubt was, so this was my first session of yours. I was so charged up and all through your sessions and all. So if I want to check your all earlier sessions, so where can I get those sessions or what like that? Sir?
A lot of videos are there in my YouTube. It may not be webinar, it may be short videos, webinars.
The topics.
Yeah. I will share you. I mean, if you are in my email list, you would have got already, or else you can get into, or you just message me. I will share you all the things.
Sure, sir.
And if anyone has asked any question in the chat, I have lost the control on the chat box. So please ask here now, because somebody is asking career in quantity surveying. See, it has limited scope, but then yes, there is scope, but then tools like Revit is going to eat away your job, but still somebody needs to be there. So I would suggest you master BIM and then parallelly continue with your quantity surveying. Any other question? Anybody?
Hello, sir. I'm Adil.
Yeah, go ahead.
Sir, what is the advantage between RCDC and SAFE?
See, if you ask me these questions, there are hundreds of software. Okay, RCDC is a detailing software.
Yes.
If you know, even CSI has a detailing software. I don't know how many of you know that. Very similar to RCDC. CSI also has something called RC Detailer. Okay. Now that is a detailing. Yeah. So that's a detailing software. You can take your result from ETABS or STAD and then get your detailing done. Now that cannot be compared with Revit, because Revit is something completely different. In your ETABS, you are having adjusted models. What you are doing is a centerline model that will not match with the exact GA. So what drawings that you get may not be exactly matching with your centerline distances. Yeah. And sunken slabs, things like that, you are not adopting. So all that you need to tweak. So you cannot, maybe you can take some RC design intent drawings from the software, not the exact drawing that we expect. The GA cannot be done. GA means your layouts. Think about you having a sunken slabs and all that. In ETABS model, you are not doing that. Then when you transfer that into RCDC, you are not going to get the sunken levels and all that. Correct. So that can happen only if you are using things like Revit.
But sir, in RCDC, we can design also pile caps.
Pile caps, you don't need a software for design of pile cap.
Yeah, I know.
Yeah. I will quickly tell you. 1 second. 1 second. Give me a second. I will quickly sketch and show what is a pile cap for your understanding. See, one pile cap, you agree it doesn't need a design because the load is directly going into the pile. Say 2 pile cap, you have 1 pile, you have another pile, you have a point load.
Yes.
Yeah. So why do you need a software for design of this? You know, W is the load coming. You know the formula, design that. You can take this as a simply supported system.
WL/4 as a point load.
Yeah, so that'll be a conservative design. You get more bottom steel. If you want to pass on some fixity, give a minimum top steel. That's the end of the story. Now, SAFE and RCDC are completely different. RCDC is a standalone plugin. It can only use these kind of formulas for design. Now, SAFE, you don't need SAFE. Again, people may not agree until I debate. ETABS is sufficient for foundation design. Yeah, ETABS and SAFE has very limited differences. Analysis engine is one and the same. There is no difference. If you want, I can show emails from CSI, which states that both uses the same technology, same method for analysis.
And sir, another also SAP 2000.
SAP is a big brother of ETABS. It's like a RAM for STAD. See, there is no need for a normal building ETABS. One thing is sufficient, even for foundation analysis. ETABS is sufficient. Believe me. Yeah.
So we can design foundation also in ETABS.
Yes. See, there is a fine difference between analysis and design. Design of a foundation is one step. So why do you want to design something using a software? It's all about analysis. Okay, coming back to this particular pile cap design, the importance of a software comes when you want to capture some load going into the soil here. See, the pile cap is on the soil. Okay, the load also will go to the pile, but some load is going to go to the earth below the pile cap. If you want to capture that, that's when you need a software. Now, ETABS can do it. SAFE also can do it. Both are same. Only thing is SAFE has some slight additional features for modeling, and that comes to play only if you are having that kind of complicated shapes. Otherwise, SAFE for ETABS doesn't really matter to me. I use ETABS for most of the medium structures. You don't need SAFE at all. And I have a course also on ETABS, a foundation using ETABS. It doesn't matter much. See, in old time, ETABS and SAFE was same. It was a single software. Only thing is, it costed say 2 lakh. I'm just telling you like a story. Okay, so 2 lakhs. Now, say you have 2 projects and 2 engineers, and one project is in superstructure stage, another project is in foundation stage. Now, 2 engineers has to share this resource, one software which you bought for 2 lakh. Now, what did CSI do? They split that into 2. ETABS for superstructure, SAFE for foundation 1 lakh, 1 lakh. Now, what is the advantage? 2 engineers can use it at the same time. That's the only difference I see in ETABS and SAFE. No other difference. Maybe there are slight fancy items in SAFE which you can use to tweak your modeling a little faster, load combinations, things like that. Otherwise, ETABS and SAFE, you can use both and achieve same results. Same thing with STAD and STAD foundations. There is something called STAD and there is something called STAD foundation. Both are same.
STAD foundation advanced also, sir.
All are same. You need only STAD for doing your foundations. The thing that additionally STAD foundation does is, see, if you have a foundation model like this in STAD, this column region, you have to mesh and give larger thickness. In STAD foundation, this comes as a stiff thing. But it's a 2-minute difference that you can achieve the same thing in STAD also. So that's what I say. Using software is one thing, understanding it and using is a different thing. If you understand what it is, you can achieve everything using STAD or ETABS. You don't need anything more.
Yeah.
I run my consulting business with 3 software: ETABS, then
AutoCAD,
Revit, and a little AutoCAD. Yeah.
Yes, sir. This is.
Yeah, tell me.
So my name is Samir Bashir. I'm from Kerala. I graduated MTech Structural Engineering, but when I applying the job for last 6 months, most of the structural consultancy asked me that I have to work at least 1 year for the site experience, and after that they can recruit to only for designing part. And most of the consultancy don't vacancy give for the freshers. They have to say that you have to do at least 1 year site experience. After that, you can enter into that designing part. Is that true?
No, that's not true. Which consultant told you this? Because I am a member of Kochi Consulting Association, even though I'm in Bangalore. I'm a member of Kochi Consulting Association. I know each and everyone who are major consultants. Let it be geostructurals, let it be Regi, let it be associated structurals, let it be anybody. I know all of them. If anybody has told you that, it's just that they don't have an opportunity right now. They didn't want to say that straight away at you.
Okay. Why most of the consultancy do not require that freshers be like a fresher graduate?
See, there are 2 things. There are 2 things. One narrows down to what I said now. Second thing is, currently we are in a very terrible phase in all of our lives. It's not a normal period. It's a pandemic and everyone has got affected, and consultants are not different. Yeah, all of us have got affected because of the pandemic. There are far-reaching implications on that. The number of projects are less, so people are relying on technology. People are relying on resource pooling and various things like that. Now, here is the place where the fresher is trying to enter. And of course, you can understand that people want people who can take decisions, and there is no enough time to teach you. So that's the reason. Yeah, so if the period was where see, when I started engineering, luckily when I started off in 2000, it was the other way around. I had opportunities every day. I can change job in every week if I wanted to. That was the kind of boom, IT revolution that was happening in Bangalore, and every consultant, every builder had opportunities. Yeah, so things have changed. It's the other way right now. So that's an unfortunate situation that we are in. It's not that people don't want freshers. Freshers are needed. And another point is this gaps in education. Have you covered it is what matters. See, certain things people don't want to train now because many people are working remotely. So that there are people who are already trained and available, and people are giving importance to such consulting, such engineers. For that matter, geostructurals last year had recruited around 4 trainees from Civil Era. So they know that people can take decisions. So it is on that covering of the gap. So if you can demonstrate, if you had attended an interview with them, and if you had demonstrated, I'm sure that people will take you if there is a requirement.
But they said that they don't have enough time to train them. They have a lot of work and they don't want to train.
Exactly, this is what I'm saying. Exactly, this is what I'm saying. All consultants want to reduce the cost. They don't have time to train you. That's a fact, because see, tomorrow I have to draw, release a drawing. So I cannot teach you modeling and other various things required. So you need to be job ready and going to them. So that's the expectation. Many students are doing that. Believe me, many students are doing it and they always get the job. You can check out with the best performers in your college. Again, since the time is bad, there might be exceptions. Otherwise, really capable students are getting job. There is no doubt about that. I mean, I'm not underestimating your skill set. Please don't think like that. What I'm saying is you should have worked in 2 or 3 real projects and you should be in a position to demonstrate. If you
I didn't get a chance to work with the project. But I didn't get any chance to work with that project.
So that is where I told you 3 different ways that you can do that. One is by your own exploration. Second is by trying to get an internship somewhere. Third is offering somebody a free work for some time. I know that it's not really sounding great when I say that, but I have done all this in my younger days. That's how it is. Or you get trained, or you try to find out from somebody who got trained and learn yourself. Yeah, but finally the result should be that at least a 3, 4, 5 floor building, you should be in a position to do from start till the end.
Okay.
See, seniors don't like you. I told you already, like if you go every day asking you, is this load to be in kilonewton or kilonewton per meter square? There is a truss coming on top of this. How do I take that load? Stair steps, how do I take that load? In the landing, there are 3 steps. How do I take that load? Nobody has time to tell you that. You should be in a position to calculate that and come up with your model perfect. Yeah. So if you have those abilities, definitely you will have a job. I think that are the kind of questions that they ask you during interviews.
Okay.
Can I ask?
Yeah.
And it's good for getting a paid internship. There is one company in Ernakulam, and they said that they have to pay an internship.
Yeah, if they are paying internship, yeah, if they are paying you good, no. Which company it is?
No, I have to pay them. Yeah, I have to pay them. I think 25,000 for 6-month internship. I think I have to pay 20,000. That's Sigma Structures.
I'm not sure. It depends on what they are going to train you. If they are systematically training you, all the things that I told you, like when you are in MTech structures, you should get training in that manner, like floating columns, how you can involve that in the analysis by eliminating the lateral loads coming onto that. So if their training is so comprehensive, then there is nothing wrong in doing that if you can afford that.
Okay, but they are using only StatPro software. They are not using any tabs.
No, you ask any of the other consultant like Geostructurals or Valsrad sir or anybody if they use STAT in their workflow.
Okay.
They don't use. Sir. Everyone are using it.
Okay. Thank you, sir.
Yeah.
So, regarding the Revit structure, is that a purely detailing software or whether it is also a design software?
See, it's not an analysis software like STAT or ETABS. It is just a building information model. It is not a detailing software. It is BIM. When I say BIM, it is much more than detailing. It is more of coordination. You can work in Revit in real time. Architect, electrical engineer, plumbing engineer, structural engineer, everyone can work together. In the sense, the coordination is in real time. If the architect moves the wall, you get to know it in real time. You don't have to wait for their drawing to come and then waste your time doing your beam layout. After 3 days, you get to know that they have moved your wall. It's not like that. It's real-time coordination. So if you ask me, is it a detailing tool? No, it is not a detailing tool. It is much more than that. Yeah, I can share you a link. I can share you a link which will explain you what Revit can do. You can message me who are interested, can WhatsApp me. I will share you that link showing what Revit can do.
Sir, what is the future of structures? Steel structures or RCC structures?
Both. In India, see, if you know JLL, they tried to bring in steel for tall buildings, but then they have failed. Mittal Group, they tried doing steel structures up tall buildings, but that has not kicked off. So the tall buildings will remain RC and precast for some more time. The main thing is about the cost. Second thing is about the ability to achieve certain things, like in apartments and all that, very long cantilevers with terrace gardens and things like that for apartments. There are certain challenges. Then sound transmission, steel structure will transmit sound. Indians are very, very susceptible to sound. Then comes maintenance, then comes fireproofing, the cost towards your maintenance and fireproofing. Steel is very, very, very bad in fire resistance. So you need to fireproof it. Yeah, so all these are going to be
expansion.
Yes. So because of that, for
So
industrial
composition of concrete plus steel is the answer.
Yeah, all that will come, but not straight away. Currently, it's next
And
5-10 years. I don't see any change. What is that?
So pre-tension or post-tension? Pre-tension and post-tension.
Yeah, that and all will be there, but then that's already there for office buildings and for other kind of commercial buildings. It's already in popular. But generally, these are all design and build items. So it doesn't come to a main consultant. Mostly it is going to be, say, people like BBR. They are design and build contractors for PT. So they will do it and pass on the frame moments to the main consultant. We take care of the main structure. So that's how it is going to be. And in seismic zones, PT is going to be not so great because that's not a great system for resisting earthquake forces. So yeah, it will be a mix of everything. It's already there. But as a beginner, there is no reason that you should be thinking about all this right now. Beam and slab is your bread and butter. Focus on that, master that. Later, you can think about all this as you gain experience. There is no reason that you should jump into a PT structure design straight away as a beginner. Focus on little things, learn that basics remain same everywhere, master this, then get into other things.
Sir, as a civil engineer, is it necessary to study that BIM MEP in a Revit?
No.
BIM model,
No.
MEP?
Not at all. As a structural engineer, you don't have to.
Okay. As a BIM modeler?
As a BIM modeler, if you want to be an all-round BIM modeler, yes, it is good. But then again, learning Revit MEP is one thing. Knowing MEP is another thing. If you don't know the basics of MEP, I don't think that there is a need that you should learn Revit MEP.
Okay. Okay.
See, hello, sir.
Yeah.
Again, sir, this is Shubham. The doubt was regarding, sir, mine was column orientation. When we are talking about the column orientation, like if you are going to finalize the positions of column, that is fine. But when we are going to talking about the orientation of column, that is whether it be L into B or B into L. Then the problem is that, sir, if we are working in STAD, we can easily get about your local axis moments, MX, MY, MZ. But how to identify those moments in a practical way, that how we can achieve those moments, how can we find that MX, MY?
Two things.
Our basically manually, how can we get those moments?
No, you can't. With experience, you can judge. First thing is that what I want to tell you, because you have various load combinations. It's not just about gravity. If it's only for gravity, you can appreciate it by saying that larger span needs larger dimension of the column oriented towards that. But then when it comes to lateral and so many other things, it's not really possible to judge everything on hand calculations. Certain experience will give you some guidance, but then that doesn't mean that everything you can do it by hand and you should do it in hand. There is no rule like that. Yeah, you can use software. And when you say that STAD is easier, then ETABS is going to be 10 times easier.
No, sir, I was not telling about that STAD is easier. Okay. My question was just only that how can I get that moments MX and MY of particular columns?
No, you cannot do everything for all combinations manually.
I was quite working on both the softwares.
No, you can't even design columns manually correctly, because you can do it only if you compromise on your effective length. If you take your effective length based on table 28 in 28 or 26 in IS 456, based on fixity condition, then you can do. But if you can really want to capture the effective length based on the stiffness, you cannot do it manually. There are much more than what you know about fixity and the end conditions of the column than table 28. That's where ETABS comes into a big picture. For example, if I show you very quickly, see, when I design a column in ETABS, there is something called frame type. This is hugely important in design. If you give non-sway, that's wrong. You have to choose between ordinary and ductile, and there is a huge difference it does when you choose it as ordinary and non-sway. Non-sway will take your effective length as per table 28, which is wrong. If you give ordinary, then you get your sway factor. Yeah, sway factor is very important to estimate your effective length. Your effective length is not 3 meters. I mean, your floor height is 3 meters. Generally, consultants take 3 multiplied by 1.2 as the effective length, which is not the real way to do. You have to estimate Q value and then understand if your floor is sway or non-sway. Yeah, you can refer annex in IS 456 for more guidance. I'm not going to cover everything right now.
No, not at all, sir.
Yeah,
not
so that
everyone is going.
Yeah, so STAD, the main weakness of STAD is STAD will need this as an input. It cannot calculate the effective length on its own.
Just within a minute, could you please elaborate about weak story and like strong sample story? About
it takes 1 to 3 hours to explain that. We'll have to have a separate webinar for that.
Sure. Thank you so much, sir.
Yeah, no problem. Any other question? We'll have to wind off now. It's almost.
Hello. Sir, just 2 minutes, sir.
Hello. Sir, what is the difference between?
Yeah, go ahead. Difference between?
So difference between the ductile frame type and ordinary frame type. When we need to use this both, sir?
Okay. See, ductile detailing is mandatory if you are in zone 3, 4, or 5. In all other zones, you can, in all other zone means it's zone 2, you have a choice. Either you can do ductile detailing or you can do ordinary detailing. Now, what do you mean by ductile detailing? You know that when earthquake occurs, you cannot design a building for full earthquake resistance because that will be uneconomic. So what we do is we make it earthquake resistant. Now, ductility is that property in the structure which will allow the member or the reinforcement to elongate and release energy. Now, how does building fall during earthquake? Simple, in a simple way, if you answer me, it's by cracking. And what is that cracking? Cracking is nothing but release of energy. Because of the ground movement, that kinetic energy is transferred into your building and the building starts moving, deflecting. Yeah. So now that energy has to be released. Correct. Now, if it was a simple pendulum, it would have moved back and forth, and the resistance between air and the friction, whatever it is, would have released the energy till it comes to a stop. Now, in the case of building, the building is not so much elastic that it cannot, it cannot vibrate like that without any cracks. It will crack. Now, the ductility is that property in your detailing which will bring in release of energy by less cracking and more elongation of rebar. So you have to follow IS 13920 and do special provisions in your detailing to make it ductile. Okay. Now, one thing many engineers doesn't understand is that ductile detailing has 1 or 2 clauses which is related to design. 95% of the things are detailing related, but 2 or 3 things are related to design. That comes, what is that? Strong column, weak beam theory. Yeah, so that check. There are few checks like that, and magnification of moments. All these things needs to be done, and that can be done by ETABS. That will be done by ETABS if you choose the design as ductile. So that's what the thing. That's the difference between giving here Ductile will ensure that your column beam strength is checked. Ordinary will not do that. Now, non-sway will not even do the effective length check. Yeah, so that's the difference.
Okay, thank you, sir. Got it. Thank you.
Hello, sir. Is there any direct internship program in your civil era?
No, we are not functioning in this pandemic. There is no direct classes for anything. We are all online right now. We will be reviewing this in February if we have to work offline, direct.
Okay. Yeah. Okay. Sir. And is there any direct classes?
No, there are no direct classes. Everything is online.
Oh. Okay.
Who is this?
Okay, in that
I missed your name.
Amir Bashir.
Okay. Yeah.
Hello, sir.
Yeah.
Sir, if there is a multi-story building of approx 20 plus floors, so as what I have learned that the size of the column increases as the height increases in the
not really.
especially.
Not really. It all depends on your scheme. Your column can have more steel at the top and less at the bottom.
Okay, so the size dimension doesn't have to relate it to that.
It can or it cannot be. I don't really reduce the size of the column as you go up. Instead, I play around with the mix of the concrete, because changing sizes as you go up, sometimes it's not possible. It depends on the forces. It's not really right to think that as you go up, the forces are less. If you look at SP16 charts, you can see that when the load is less and when the moments are more, you can have more steel. Why is it so? That's because your design is interactive. It is not just dependent on one force. It's about the interaction of three forces. So you can have situations where your top of your column can have more steel requirement or size requirement at times. Yeah, but if your scheme is more or less correct, then yes, maybe you can have situations where you can reduce the size as you go up. But better than that would be to increase the concrete grade at the bottom, keep a uniform size. So M50 at the bottom, and at the top, after some floors, say after 5-10 floors, you make it M20 and then keep the same size. Because otherwise you will have stiffness variations. You will have a difficulty with detailing and all that, and that will not be good for seismic performance. Again, it has to be taken case to case. I cannot give you a blanket answer for that. So it depends on your project. But this is what I do generally. I keep the same column size. Most of the times it may be possible. It depends on the project. And then you increase your column concrete grade at the bottom, reduce the grade at the top.
And sir, if the multi-story building, if a multi-story building has more than 20 floors, then how the size of the column or any size of the beam is decided on designing?
You have to do, I mean, for one floor, how you do the same thing for multiple floors, but there are more concepts into it. That's the only difference. You can adopt your judgment plus a trial and error, both together. Trial and error as in you have to model it, then understand the behavior, change your stiffnesses, change your sizes, change your locations, play around and find out. There are, ETABS allows you to do that very fast. There are tools and techniques that you can adopt.
Yes, sir. And sir, one more question, sir. Does your company gives the opportunity of a graduate engineer trainee like something?
No, at this point in time, we don't have anything at the moment. Okay, so
would you recommend some of the companies that do so?
Yeah, current pandemic time, we are not doing anything direct.
So any other company like which is interested for graduate engineer training programs?
You can email me. If I find anybody, I will connect you. Or if I know about it, I will let you know.
Okay, thank you, sir.
So we have to wind off. We are almost 2 hours. Yeah.
Sir?
Yeah, tell me.
Sir, yeah, how good is Revit in detailing steel structures like connections and all?
now they have developed, the recent revisions are good, but then it's not as good as Tekla, as per who works on Tekla. But then, yes, it has fair bit of information, fair bit of advancement, but not.
My question is,
not
I have learned Revit structures, and I have been working on that as well. But the problem is now he is my senior. He was working at KLJ in Vadodara actually. So he told me to work on Tekla, and then he
for
might
steel
give me an
structures,
opportunity to work.
for steel structures,
Yes,
Tekla
yes,
has
exactly.
some advantages. Yes.
That's why I'm asking, is there any unified software which I can learn? And because everywhere I go, they tell me about different softwares. Like when I went to Webcoast, they were telling me to work on
No, for
Midas
steel
and all,
structures, definitely
for
it
the
is
bridge.
Tekla.
Okay.
Yeah.
Thank you, sir.
Yeah.
So last question.
Yeah.
So I have a G+3 building structure. So in the ground floor column, the steel is 16 mm bars, 4 numbers. But the upper stories, the steel is increasing.
Have you done seismic analysis?
No, not seismic analysis. General normal residential building.
No,
But
normal
the
residential
PT
building
of a
also
column
needs
is
seismic
increased.
analysis.
Yes, sir.
Normal residential building also needs seismic analysis. All buildings need seismic analysis. And coming to your question, at the upper level, I don't know, because it depends on your scheme. You might have changed something, the beam position, it may not be typical. If it is typical, it is unlikely that you will have that behavior for a gravity load case. I don't know. I will have to see that.
But
no idea, because until and unless see what you have done, you might have done some mistake also, or your scheme may be doing that. I don't know what it is. Generally, for a gravity load case, if it is a typical building, then as you go up, since the columns are stopping,
steel
and
is ready.
a very slight chance, but then maybe it depends. Are the all floors typical? Even the terrace beam and slab, is it same as the lower level? It may be due to the discontinuity of the column, or it may be due to less load and larger moments. So it depends on what your moments in the columns are. Load is going to decrease, but the moments are going to sometimes increase. Less load and larger moment can create more steel requirement in your column. So it's
upper
not
floors.
Yes. So it's not something which is not unheard. It is
So
something possible.
It's not the fault of software.
I don't know. No, software, if you are using an original software, it won't be giving you any mistake. It will be going by what you have modeled. But now in your model, if there is a mistake, it's up to you to find that out. So if you find that out, you can be sure about it. I cannot say anything offhand because I don't know. I have to see that. Until and unless I see it, I won't be able to tell if there is a problem with that.
So what about the ebook that you have told us earlier in the WhatsApp group?
What is
going
that?
to share that ebook that you are going.
I will send you an email with that.
Okay, thank you.
Yeah. So let's quickly wind off. It's 1 o'clock. We have done more than 2 hours. So I wish you all the best. We will see you in another webinar soon. If anybody has any more questions, you can either post in the group or you can email me. These two medium you can use. And if anyone is interested in any of the courses that I have mentioned with the offer that I gave you, you need to contact me very soon, because that's not forever. That's for a few hours or a day. So I wish you all good luck. You can keep asking me doubts in the group. Even though I have an advanced course, that doesn't mean that you cannot ask there. You can ask me, but only thing is, as time allows, I'll be able to share replies. I will try my best, but then sometimes I'll be busy, sometimes I'll be free. It depends on that. And those who are enrolling for the premium community, you are going to get premium courses are going to get a premium community where my engagement level will be higher as well. So maybe I'll take one question. I can see 3 raised hands. If you have one last question, please ask one of you. Nothing, I guess. So let us wind off. We'll see you in another webinar soon. So get back to me.
So,
Yeah.
I used to design this deep beam pile cap through bending theory, but the first assumption of bending theory is that plane section remains plane. That is not valid.
Yeah.
So how we can design this pile cap through beam theory?
See, all these are theories, beam theory and truss theory and all that. So there are certain conditions listed down. So if that is met, you can go by that, and both are thumb rules. If you want the exact, then the way is to idealize it, bring in the soil structure interaction as well, and it involves all that. Yeah, so either if you are going by hand rules, that's acceptable, but then ensure that the conditions laid down in the book and codes are met. So if all the conditions meant for truss theory is meeting, then go by truss theory. If everything is meeting the other one, go by the beam theory. It doesn't affect you. It will work. And why it will work? If there is a slight difference, I will share you one. I think I have already shared, but then I will share you again and tell the significance. It's about the redistribution ability. So that doesn't matter. Slight variance will not matter.
So you said in the development length that the development length can be reduced if the stress level in steel is lesser than its capacity.
Yes.
But during the seismic activity, it will transfer the force equivalent to its capacity, and the adjoining component is not designed for that.
So you need to take care of all that. I mean, I'm not just blindly saying that you can just ignore it. You are doing a seismic analysis and then arriving at the stresses, and then upon that you are reducing it. I mean, you are increasing the steel, which means that you have more capacity. So stress reversal, all other aspects needs to be taken care of.
Thank you, sir.
Yeah. Okay, so let us wind up.
Question. So small last question.
Yeah.
Sir, as we used to study design of beam in a rectangular shape in college, but when I came here to Noida, I saw variants type of structures like curved beam, curved columns. So how these reinforcement detailing should be done?
You are talking about a curvature in plan?
No, curvature in elevation.
What is the cross section?
Like so curved beam is curved, like we used to see normally that beams are
Yeah, but still it is rectangular. Only thing is that in elevation it is curved, right?
Yes, sir.
Yeah, so that, see, the only way that you can capture all this is by doing the modeling properly, accurately, so that all the effects are captured in the model. You cannot derive everything from first principles. If you do that, you have time only for that. You have seismic resistance and various things, demands that you need to meet. So that's why tools like this are going to help you. So if you model that, how it is existing in your project, the same way, if you achieve the model, then it will definitely give you the forces also accordingly. So you take the forces and design that. There is no other thing that you can do with these.
Yes, sir. Thank you, sir.
All right, so let us wind off. Okay, so thank you for being in the webinar. I hope it helped you in one way or the other. We'll meet in another webinar very soon. So thank you so much. Wish you all good luck. Get back to me in case if you are looking for the training. Yeah, thank you.